Hello everyone, in this video we're going to discuss the reader-writer problem in process synchronization. What is this reader-writer problem is, we have a reader and a writer process which share a common object such as a file or a data variable or a database between them. And the reader process performs only the read operation and the writer process performs a write or a update operation on the shared object. For example, in a banking application, the balance check is a reader process, whereas the withdrawal and deposit will form the writer process. Now, the synchronization problem here, requirement here is that the read and write operation must always be consistent. In the sense, the read and write operation must always be giving the correct results. There should not be any race condition in that. So, in order to implement the solution, we need to understand few things. That is, the read operation is a shared operation, meaning end process can perform the read operation at the same time without any synchronization issue. There is no problem with end process reading at the same time, whereas the write is an exclusive operation. That is, when the write operation is taking place, there should not be any read or a write operation happening at the same time. For example, when I am checking my bank account balance, I can check at the same time using my Google Pay, my internet banking, and at the ATM at the same time. There's no issue in that. But to perform, when I perform a withdrawal or deposit, it should happen one at a time. And also, when I perform the withdrawal or the deposit, I cannot be checking my account balance. So when the write operation is happening, there should not be any other write operation or the read operation. Now, let's look into the algorithm. So in order to implement the solution, these are the things that are shared between the reader and the writer process. So first one is a binary mutex, RW mutex. So this mutex is used for the for protection of the write operation. So this is used by the reader and writer process to ensure that the write operation is exclusive. And the second binary semaphore mutex, this is used to ensure that the variable count between the readers is exclusive. And we have a variable count which is used to keep track of number of reader processes. Now let's look into the writer process code. So the writer process code is fairly simple. So whenever the writer process wants to perform a write operation, so it uses RW mutex to log the critical section, to log the write operation. It calls wait RW mutex to log the wait operation. Once the writer process logs the write operation, no other reader process or the writer process will be able to perform the read or write operation until that process releases the RW mutex by calling signal. So the writer process structure is fairly simple. In the entry section, it calls wait of RW mutex by locking the write operation, and in the exit section, it unlocks the operation by calling signal RW mutex. The code of the reader process is quite interesting. So as we have already discussed, n number of reader process can be reading at simultaneously. So in order to keep track of the number of reader process, we are using a variable called as a read count. So this read count variable is a shared variable between the reader process. And the logic that we are using is the first reader process is going to obtain a lock on the write operation, meaning that when the reader process is performing read operation, the writer process should not be performing write operation. Hence, it's the responsibility of the first reader process, you can see here, to log the write operation. And the last reader process responsibility is to unlock the write operation. Okay. And as I told you, the read count is a shared variable between the reader process. The reader process increment the read count whenever they want to perform the read operation, and they decrement the read count when they are done. So this read count variable, as it is shared between the reader process, the increment or the decrement operation is again a critical section. Hence, it happens within the guards of wait mutex and signal mutex. So you can see here this wait mutex and signal mutex is for this read count operation. Same applies for your exit section also, when the read count minus happens within the wait mutex and the signal mutex. And what is this part? This part is the first reader process locking the write operation, right? And what is this part? This part is the last reader process unlocking the write operation. So summarizing here, as you can see here in the entry section of the reader process, the reader process first calls wait mutex and then updates the or increments the read count, and it checks if it is the first reader. If so, it calls wait RW mutex, indicating it's going to lock the write operation. If already write operation is happening, then the reader process is stuck here and it cannot proceed until the write operation completes, right? So if the write operation is not happening, the process will continue. If the write operation is happening, the reader process will be stuck here. Suppose the writer operation is not happening, it will lock the write operation, and then now it will call signal mutex so that any other reader process which want to access the read count can do so. Now the process will happily read, right? So once the process is done reading operation, it has to decrement the read count. So it will call wait mutex. It is updating the read count, which is a shared between the reader process. It calls wait mutex and then decrements. Now it checks if it is the last reader process. If it is the last reader process, then all the reader processes are done. There are no reader processes. If any writer process is there waiting to perform write operation, it can proceed. Hence the reader process will call signal RW mutex. Now as the process is done, it will call signal mutex, releasing the read count, right? So this is the simple and yet interesting code of the reader process. This is called as a first reader writer solution to the problem. The problem with this approach is that it gives more priority to the reader process. It gives higher priority to the reader process, and due to which the writers may have to starve. So this is the only drawback of this solution. So that's it. That's it. The first reader writer problem. Thank you. Now we will see the execution of reader writer code. So here you can see we have included the header files stdio.h, stdlib.h, pthread.h to create the reader and writer threads, and semaphore.h for creating and managing the semaphores. Here we have two integer variables, count and rcount. Count is a data shared between the reader and the writer process. So they are going to update this shared variable count. Reader process is going to read the count, writer process is going to update the count. And rcount is the number of reader count. So rcount keeps track of number of reader processes. We are using two semaphores here, mutex, which is used to update the count variable. So that mutex to update the rcount variable. The readers share rcount, right? They increment the rcount when before reading, and they decrement the rcount while done reading, once done reading, right? So that is done updated using mutex, and RW mutex is used by the reader and writer process for exclusive access to the write operation, right? So to begin with the writer code, you can see it's taking the writer number as an argument. Now here we are typecasting the void star to int, and then we are calling sumWait RW mutex. So it's going to log the write operation if at all, if it is available. Otherwise it will wait there. Then once it obtains a log to the write operation, it prints writer %d, writes page number %d. So you can see here the shared variable count is updated by the writer process. Once the write process is done, it's going to call sempost RW mutex, releasing the log on the write section, right? And then next, reader process, it's also taking the reader number as an argument. Here we are typecasting the void star to int. Then now the reader process has to increment the reader count, right? So it will call sem_wait mutex, increments the read count. Now it checks if it is the first reader, right? Then it tries to log the write operation, right? If the write operation is not available, it will wait. Otherwise it will log the write operation. Now once the read count is updated, it releases the r count by calling sempost mutex. Now the reader is inside the critical section. It prints reader percentage D reads the page number count. So here you can see the reader is reading the count. Now the reader is done with reading, so it has to decrement the read count, right? So it will call sem_wait mutex, right? And then it will decrement the read count. All the readers are sharing this read count, right? So when they update, when they increment and decrement this read count, it must be done in the sem_wait mutex and sem_post mutex. So it decrements the read count. Now it will see if it's the last reader process. If it is the last reader process, then it will call sem_post RW mutex, release in the write section, write operation. Right? So this is the exit section of the reader process. Now in the main, it's very simple. First we are initializing the mutex here. We are initializing mutex to 1, the third argument. Now the 0 in the middle indicates it's for the process, as it's for the threads. Right? If it is for the process, it should be set to 1. Similarly, we are initializing RW mutex to 1. Now this array A is going to store the reader numbers and the writer number. 1, 2, 3 reader number, writer number, and 1, 2, 3 for reader. P is going to store the thread ID. We are creating threads for reader and writer, right? The thread ID allocated by the system will be stored in this P. Here I'm using a for loop running from 0 to 3, and we are creating a writer threads. You can see we are creating threads, and the thread is going to execute writer function, and we are passing the first three entries of this array A, 1, 2, 3 to pass, right? And then we are running the second for loop from I equal to 3 to 6, that is 3 times. We are creating 3 reader processes, right? And then we are calling for loop for 6 times, and we are calling pthread join so that this main thread will wait for the readers to read, all the readers and writers to complete their operation. Now we will execute this code. So you can see here, writer writes the page number 1. So writer has updated the count to 1. Writer 3 has updated the count to 2. Now reader, you can see the reader is reading the updated count 2. Right? This shows that there is a synchronization between reader and writer process. Now writer 2 is executing, so it updates the count from 2 to 3. Then the reader reads the count 3, and the reader 1 reads count 3. So you can see here there's a synchronization between the reader and the writer process. Now I'll execute once again. So you can see here the order is changed. Writer has updated you can see writer 1, writer 2, writer 3, they have executed in that order, 1, 2, 3. And then you can see the reader has read 3, 3, 3. So you can see that's no matter what order the writer and reader process are created, but they are the values that are written and read are consistent. So this is all about reader and writer process. Thank you.